Hi everyone! What we're going to do now is create our very first pod in Kubernetes. If you remember from the previous episode, Kubernetes doesn't work directly with containers. It works with pods. Before we jump fully into the hands-on part, let's understand what a pod actually is. A pod is the smallest deployable unit in Kubernetes, and in most cases, a pod contains one container. Here on the left side, we can see a Kubernetes node, and inside that node, we have multiple pods running. Each pod has its own IP address, shared networking, shared storage, and one or more containers inside it. So even though we usually think about containers, Kubernetes actually manages pods, not containers directly. On the right side, we can also see how easy it is to create one using kubectl run, and then verify it with kubectl get pods. And once the status becomes running, it means Kubernetes successfully created and started the pod inside the cluster. Now let's create our very first pod. This command tells Kubernetes, create a pod called nginx using the nginx container image. Notice how simple this is. We are not dealing with servers directly. We are not installing software manually. We just declare what we want, and Kubernetes handles the rest. And after a few seconds, the pod should start running inside the cluster. This command lists all pods running in the current namespace. Here we can see the pod name, its status, restart count, and age. If you see the status running, that means Kubernetes successfully pulled the image and started the container. Now let's inspect the pod in more detail. The describe command gives us much deeper information, events, container details, image information, IP address, node assignment, and possible errors. This command is extremely important in real environments because it's one of the first things engineers use for troubleshooting Kubernetes issues. And finally, we can check the container logs. Even though nginx is simple, this is how you normally inspect application output inside Kubernetes. In real projects, logs are critical for debugging applications, startup failures, or connectivity issues. These logs confirm that nginx started successfully inside the pod. Kubernetes pulled the image, started the container, and now the application is running correctly. Let's remove the pod. Kubernetes immediately terminates the container and deletes the pod from the cluster. Later in the series, you'll see why manually created pods are usually temporary, and why real workloads normally use deployments instead. Now let's create our first Kubernetes manifest manually. We'll keep everything organized inside a dedicated project folder. Let's create our first Kubernetes YAML manifest. This defines the Kubernetes API version we want to use. And here, we define the type of Kubernetes resource, in this case, a pod. Metadata contains information about the resource, like the pod name. One important thing about YAML, indentation matters a lot. Spacing defines hierarchy in YAML files, so even small indentation mistakes can break Kubernetes manifest. The spec section defines the desired state of the pod. Here we define the containers that will run inside the pod. This pod will run a container called nginx using the official nginx image. Notice the indentation levels. YAML is very sensitive to spaces. This is one of the most common beginner mistakes in Kubernetes. To demonstrate how important indentation is in YAML, I'm going to intentionally leave the containers line incorrectly indented. As you can see, Kubernetes throws an error because the YAML structure is invalid. Now, let's fix the indentation. And now, it works correctly. This is why indentation is extremely important when working with Kubernetes YAML manifest. Now let's verify the pod status. And as we can see, the pod is now in running state. This means Kubernetes successfully validated the YAML manifest, created the pod, pulled the nginx image, and started the container correctly inside the cluster. At first, pods may appear in states like pending or container creating, but once everything is ready, the status changes to running. Then let's inspect the pod created from the YAML manifest. This allows us to see detailed Kubernetes information like the pod IP, the node where it's running, events, container details, and image information. And here, we can see the application logs directly from the container running inside the pod. And now we remove the pod using the same YAML manifest. This is another advantage of declarative Kubernetes workflows. The same file can be used to create, update, and delete resources. And now the pod is gone. And this is actually an important concept in Kubernetes. Pods are designed to be temporary and replaceable. If a pod disappears, Kubernetes can create another one automatically depending on the controller managing it. Right now we created pods manually, so once we delete them, they are permanently gone. But in real production environments, engineers normally use deployments and replica sets to keep applications running automatically. Today we learned what a pod is, how Kubernetes manages containers, how to create pods with kubectl, how YAML manifests work, and why indentation is critical in Kubernetes configurations. In the next episode, we'll learn about deployments and replica sets, where Kubernetes starts managing pods automatically for scalability and self-healing. Thanks for watching, and see you in the next video.